In this video, we're going to solve a triangle using the law of sines. We'll start by taking a look at the given information. In this triangle, we are given an angle, a side, and an angle. This is called an ASA triangle. We can use the law of sines to solve this triangle by first determining the value of angle C. Since the sum of all angles in a triangle equals 180 degrees, we know that 20 plus 20 plus x equals 180. Solving for x, it's pretty easy to see that x, or angle C, equals 140 degrees. Next, we'll apply the formula for the law of sines to find the sides A and B. The law of sines says that sine of A divided by A is equivalent to sine of B, that's angle B, over sine B, which is equivalent to the sine of angle C divided by side C. Since we know the values for angle C and side C, we'll use these values, sine of 140 over 4, to help us solve for our two unknown sides. Let's solve side A first. So sine of angle A, or angle A, is 20 degrees. So sine of 20 divided by side A. To solve for A, we'll cross multiply. So we have A sine of 140 equals 4 sine of 20. And then here we can divide sine of 140 from both sides. And our result is that length A is equivalent to approximately 2.13. Next, we'll solve for side B. We can certainly apply the law of sines again, repeat the same process, and solve for side B. Or, if we notice that we have two angles of 20 degrees, giving us an isosceles triangle, then side B will be equivalent to side A. So this triangle is completely solved, as we now have the measures of all three sides and all three angles. Let's take a look at one more example. Not all triangles can be solved easily using the law of sines. there are certain situations in which we have what's called an ambiguous case. The ambiguous case occurs when we're given two sides and an angle for the SSA triangle. In an SSA triangle, there are several possibilities. There may be no triangle. There may be one right triangle. There may be one triangle of another type. Or there may be two triangles. How do we determine whether an SSA triangle fits one of these cases? If there is no triangle, then the given side A will be less than the triangle's height equal to B sine of alpha, where B is also a side, and alpha is our given angle. If we have one right triangle, then side A is equal to the triangle's height, which is equal to the length of the other side B times sine of some angle alpha. If there's one triangle, then side A is greater than or equal to side B, and side A is greater than the height equal to side B times sine of alpha. If there are two triangles, then side B is greater than side A, which is greater than the triangle's height equals B times sine of the angle alpha. Suppose you're given information about a triangle where side A equals 7, side B equals 5, and angle alpha equals 70 degrees. In order to establish the relationship between our sides and our triangle's height, we'll use the formula H equals side B times sine of alpha, which is equal to 5 sine of 70 degrees. What we're finding is this portion right here. H equals B sine of alpha. 5 times sine of 70 degrees is approximately equal to 4.70. So let's compare side A to our height H. Well, if A equals 7 and our height H equals about 4.70, we see that A is greater than H. So this means that we must have one triangle. We can't have two triangles because if we did have two, side B would have to be larger than side A, and clearly that is not the case here. It's also not the case that we have no triangles, because no triangles occurs when A is less than H, and here obviously A is greater than H. We also don't have a right triangle because in the case of a right triangle, A is equal to H. So again, reaffirming, we have one triangle because side A is greater than or equal to side B, and also side A is greater than h, which is found by calculating b times sine of alpha. Now we can solve our triangle. Recall that the law of sines says that sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. I have both side A and angle alpha, which is angle A. So I can say that sine of 70 degrees over 7 equals sine of angle B over side B, which happens to be 5. To solve for sine of B, or to be consistent, we could call it beta, since we're calling angle A alpha. We'll use algebra to solve. So we have 5 times sine of 70 degrees over 7. And as it turns out, there are two angles between 0 and 180 degrees for which sine of B, or beta, is equal to 5 times 70 degrees divided by 7. Those angles are 42.2 degrees or 137.8 degrees. So which one do we use? We have to throw out the angle 137.8, because if we were to add that to 70 degrees, the result would be in excess of 180 degrees. And we know that there are no triangles whose angles sum to more than 180 degrees. Every triangle, the angles of every triangle sum to 180 and exactly 180. So we throw this result out, and we use angle 42.2. From this point, it's fairly straightforward to find the final angle. Again, since we know the sum of all angles in a triangle is 180, we subtract our known angles, 70 and 42.2, and this leaves us with about 67.8 degrees. At this point, all that's left for us to find is side C. Using the law of sines, sine of alpha, 70, over side A, which is 7, is equal to sine of C, which is 67.8, divided by C. We'll use algebra. C sine of 70 equals 7 sine 67.8. Divide sine of 70 from both sides. And it turns out that side C is approximately equal to 6.90, or 6.9. So now we have solved this triangle. Hopefully these two examples were helpful. In our next video, we'll be taking a look at the law of cosines. See you next time.